Right now, a machine the size of a small car is hurtling through the pitch-black depths of space. It is completely alone. Drifting nearly 15 billion miles away from Earth, Voyager 1 is the most distant physical object humanity has ever created. Launched in 1977, the probe provided our first detailed look at the rings of Saturn and Jupiter, eventually discovering 48 new moons and providing over 67,000 images that defined our modern view of the outer solar system. Since then, it has kept going. Traveling at 38,000 miles per hour, Voyager 1 pierced the heliosphere, the protective magnetic bubble generated by our sun, to become the first human-made object to navigate the vacuum of interstellar space. But its endurance is finite. This chart tracks the probe's remaining power, which drops steadily as its plutonium generators lose about 4 watts of output every year. By 2036, that energy supply will be exhausted. At that point, the spacecraft will go silent. Unable to communicate or adjust its course, it will become a drifting ghost ship. Its current path is headed toward a star with no confirmed planets, leaving the probe to wander the void indefinitely. For this dead machine to ever find a destination, like Proxima Centauri b, the nearest exoplanet to Earth, it must survive a brutal, unpowered 75,000-year gauntlet through the most dangerous environments in the galaxy. 30,000 years into the future, the probe reaches the Oort cloud. This is a freezing frontier of our solar system, home to trillions of ancient, jagged, icy bodies and comets that have remained unchanged since the planets first formed. While it seems like an impassable minefield, the Oort cloud is so vast that its debris is spread incredibly thin. Statistically, the tiny probe is likely to slip past these billions of comets without ever making physical contact. However, Voyager's current trajectory will never lead it to another world. Without functional thrusters to steer itself, the probe's only hope for a new destination is a rare, high-stakes gravitational encounter. Some scientists suggest the Oort cloud may hide a rogue planet, a world roughly the size of Neptune that was ejected from another star system and captured by our sun's gravity. In this theoretical scenario, Voyager would be pulled into the rogue planet's gravity well. By passing behind the planet, the probe would steal a fraction of its orbital momentum, slingshotting onto a new trajectory aimed directly at the Alpha Centauri system. This maneuver provides the necessary course correction, but it also commits the aging, unshielded aluminum hull to another 45,000 years of physical decay. By year 40,000, Voyager faces a threat more persistent than rust. Deep space is saturated with galactic cosmic rays, high-energy particles that move at nearly the speed of light. Having spent millennia outside the sun's protective bubble, the probe is continuously pelted by these radiation bullets. Without an atmosphere to deflect them, they strike the 1970s-era hull with relentless force. This radiation slowly alters the aluminum on a molecular level. After 40,000 years of bombardment, the metal becomes incredibly brittle, losing its flexibility until the entire structure is weak enough to shatter like a ceramic plate upon impact. In year 75,000, the probe finally reaches Proxima Centauri b. This exoplanet is tidally locked to its star, leaving one side trapped in permanent darkness, while the other is scorched by extreme ultraviolet radiation. The encounter is violent. Dragged in by the planet's gravity, the brittle probe hits the atmosphere at 20 kilometers per second, a velocity far beyond what its aging frame can withstand. Without a heat shield, the friction of entry causes the temperature to spike instantly. The external instruments, the high-gain antenna, the camera booms, and the magnetometers, vaporize into plasma in seconds. Only the most heavily shielded components survive the initial fire. The heavy-duty shells surrounding the plutonium batteries are the only parts of the machine dense enough to reach the surface. Voyager 1 is reduced to a cloud of metallic dust, scattered across the alien landscape by hot, high-speed stellar winds. Amid the wreckage on the alien surface, a single piece of human history remains: the golden record, a disc of gold-plated copper housed in an aluminum jacket. A committee of astronomers led by Carl Sagan designed this record as a cultural time capsule. They filled it with music, greetings in 55 languages, and snapshots of life on Earth, intending it as a greeting for any extraterrestrial life that might find it. But the long journey across the void takes a toll. Over 75,000 years, the surface of the disk is sandblasted by high-speed interstellar dust. This abrasion wears down the delicate, high-frequency grooves that hold the record's analog data. The music of Bach and the sounds of Earth's crickets are permanently sanded away. While the audio is lost, the record's most vital message is also its most durable. Etched deeply into its metallic cover is a pulsar map, a series of 14 lines radiating from a central point. These lines use the precise mathematical timing of dead stars to act as a cosmic lighthouse. By measuring the frequencies engraved here, an advanced civilization could triangulate our sun's exact position in the galaxy. Voyager 1 leaves behind a physical return-to-sender marker, a mathematical coordinate etched into metal that can endure 75 millennia in the dark.